Hi everyone, in this video we are going to look at one classic mistake that happens when trying to expand something like this, where a square is applied to a bracket. So the classic mistake that is found is just to apply the square here to the two terms inside and to write this as x squared plus 9. So we are going to look why this thing is absolutely incorrect. So this x plus 3 squared means that the x plus 3 is multiplied by itself. So you can write it as x plus 3 multiplying x plus 3. And if you expand these double brackets, you see that you have 4 terms coming out of the brackets, like this. So the x multiplying the x will be the x squared indeed, but the x multiplying the 3 will give you a 3x. Then you have the 3 multiplying the x here that will give you another 3x. And then you have the 3 multiplying the 3 there that will give you a 9. So you see that with this expansion right here, you find the x squared, you find the 9, but you're forgetting about the two cross products. The x is also multiplying the 3, and this 3 is also multiplying this x. There is a very visual way also to remember that we have two cross products here, and that is to interpret this thing here as an area. If you have a look here at the square that I've drawn, you see that this length is x, this one is 3. So the total length here is x plus 3. And so if you want to work out the area of the square, you're multiplying x plus 3 by x plus 3, you do get x plus 3 squared. And so this total area is made of 4 different parts and not only 2. You see this one here is the area of this square, so it's x times x, it's x squared. The area that we have here is 3 by 3, so this area is equal to 9. And you see that we can't forget about this one here and this one. Here we have a rectangle that is 3 by x, so this area here is 3x, and the other one is also 3 by x, so its area is again 3x. And you see that here we find the two cross products that we had in this expansion here, in addition of the two squares of x and 3. Let's illustrate once again this fact with a numerical example. If you try to work out 12 squared, you can write this as a 10 plus 2, which is squared. We know that 12 squared is 144. So let's see if we can actually expand this thing to check that it's 144. If you only go for 10 squared, which is 100, plus 2 squared, which is 4, you find 104. And so you're missing the 40 that you have there. The thing is that if you rewrite this 10 plus 2 squared in full, like showing that it's 10 plus 2 multiplying 10 plus 2, you see that the 100 here comes from the 10 times 10, the 4 comes from the 2 times 2, but let's not forget about the cross product. We have a 10 times 2 here and a 2 times 10 here, each of them making an extra 20 when you expand. And you see that this sum here is 144 indeed.